Hey guys! Today we're going to calculate different values using the pH and the pOH scale. I've already introduced one basic equation. Now I'm going to introduce 5 more so we can do some calculations to solve for some unknown variables. So since they are treated identically, the equations that I'm going to introduce can be used for both pH and pOH. So the first equation, you can find the pH using the following. And I'm going to write both equations even though they're the same. pH equals negative log and then the number of H plus ions. So notice this is a logarithmic function. You are actually going to use the log button on your calculator. And on my calculators in the classroom, that button is directly underneath the second button. And then we have pOH equals negative log and then the number of OH minus ions. So notice exactly the same equations. The only difference is if it says H and H or OH and OH. Now in order to go backwards to solve for the number of ions, we're going to again have to use logarithmic relationships. And we have the number of H plus ions equals 10 raised to the negative pH value. And then again, the number of OH minus ions equals 10 raised to the negative pOH value. So the way that this is going to be set up, I'm going to give you either the number of ions or the concentration, which is the same as the number of ions, or I'm going to give you the pH value, and I'm going to expect you to find one of the other 3 relationships. So these are 4 of our basic equations for this section. Now we're going to do some examples. First, calculate the pH of a 0.0025 molar solution of HCl. So the molar solution, this by definition is the number of moles per liter. If you have a capital M value, that is equal to the number of ions. So we're going to use this equation of pH equals negative log number of H plus ions, and we're actually going to plug this number in right here. So pH equals negative log 0.0025. Because remember, 0 is very acidic, 14 is very basic. So for this second example, what we have to pay attention to is the fact that our question, find the pH, does not match the substance that's given to us. Find the pH of a 2.75 molar solution of NaOH. Since these do not match, I have to do more than one step. So the previous example, I was able to use the equation of the pH equals negative log number of H plus ions. But in the example above, pH and HCl matched. So here, if I plug this into that equation, which I'm going to do, that is the number of ions, instead of telling me the pH, it's actually going to tell me the pOH, since that is the chemical formula of that solution. So negative log number of OH minus ions. So these equations are interchangeable, but based on the chemical formula given is going to tell us which value we're actually calculating. So pOH equals negative log 2.75. And my pOH value is 0.44. Now if we go back to that first basic equation, 14 equals the pH plus the pOH. We just solved for the pOH. So plug in that answer for pOH, then I'm going to subtract 14 minus that answer. My answer for my pH value is 13.56. So that tells us this substance is very, very basic. It has a high concentration, which means it has a high level of ions separated out. So when we calculate the pH level, the fact that it's almost 14 means it's a very basic substance. So we have one last equation that's going to be very handy. If I give you the number of H plus ions, and you wanted to find the number of OH ions, in the past or using the equations that I've already given you, that's going to take 3 to 4 steps. So I'm going to give you this equation which makes it only take 1. So if we know the number of ions of one of the substances, we can automatically solve for the other. So the number of unknown ions is equal to 1 times 10 to the negative 14 divided by the number of known ions. So notice I put known and unknown because pH and pOH can be plugged into either of these locations. If I know the number of pH ions, I can solve for the OH ions. If I know the number of OH ions, I can solve for the H ions. They are interchangeable. So we're going to use that on the next slide. The H plus concentration in coffee is 1 times 10 to the negative 5 molars. What is the OH concentration, and is this substance considered acidic, basic, or neutral? Okay, so first, number of unknown equals 1 times 10 to the negative 14 over 1 times 10 to the negative 5. And when we calculate that out, our unknown ions end up being 1 times 10 to the negative 9. And since I knew H pluses, that means these are the OH minus ions. Now I'm going to look at the concentration. I'm going to use the other equation to solve for the pH value, so I can tell you if it's acidic, basic, or neutral. So pH equals negative log H plus ions. pH equals negative log 1 times 10 to the negative 5. My pH value is 5 on the pH scale, so that means that this is considered acidic. So this saves us a lot of time just doing that simple division, and then we can go back to the first equation to solve for the unknown. So when I see you next, we're actually going to practice with this a lot. I'm going to give you either the pH value or the number of ions, and I'm going to ask you to solve for an unknown. I may have you do 2 or more steps in one, like this example, where we solved for number of ions as well as the pH or the pOH value, but I just want you getting comfortable with it so you can solve for the unknown variables. So I'll see you tomorrow so we can practice.